let's review these exponent rules before we do the common base solving practice. Remember, we have a fraction here. When you have the 14 over 7, you're going to divide those coefficients. So 14 divided by 7 is 2. Then there's no other n in this expression, so I'm going to leave that as just n to the third. When I have a fraction, we are subtracting exponents. I'll have a 1 minus negative 2, which is 3. So that's actually your final answer, 2n to the third, b cubed. B is a little bit different. I'm going to start by getting rid of those parentheses. I'm going to, what we say, distribute the negative 2 to each part of the expression. Okay, the 3x stays the same. Now, when I multiply here, negative 2 squared is positive 4. X to the 5th squared is x to the 10th, y squared. Now, you don't have to distribute here. We don't have plus or minuses, so it's not the same as like how you would distribute to collect like terms. All you have to do is now multiply straight across. You can even get rid of these parentheses at this point if you want, and just have 3x times 4x to the 10th y squared, if that helps you. All you have to do is multiply the numbers together. 3 and 4 is 12. Then x to the first times x to the 10th, they have the same base, so we add the exponents, and then y squared. All right, letter C. When I have the exponent of negative 1, I'm going to distribute that exponent to each piece and part of this expression. So I get 1 to the negative 1 over b to the negative 2, f to the positive 3. Now remember, a rule about negative exponents is that the terms with a negative exponent flip position. So the f to the third is positive. He stays put. The 1 moves to the bottom because it now will have a positive 1. And the b moves to the numerator to have a positive exponent. You could also rewrite that as just b squared over f cubed. You do not have to write the 1. All right, and finally, D, 49 times x to the 0. Well, make sure you recognize that the 0 is only as an exponent on the x. So it's 49 times 1, which is 49. So we should know those exponent rules before we get down to the problems here for solving with a common base. All right, so 3 to the 2x equals 3. These both have a base of 3, both sides of the expression. The exponent on the right is 1. So if they have the same base, you get to take the exponents and set them equal to each other. And all you have to do is solve for x by dividing by 2. So if x equals 1/2. If you want to check your work, this is a really easy type of problem to check your work on. If I put that 1/2 in here for x, I'll have 3 to the 2 times 1/2 power. Well, 2 times 1/2 is 3 to the first, which is exactly what we had on the other side. So that's an easy way to check. B is also pretty easy because they also both have a base of 2. So all you have to do, because the base is 2, is set the exponents equal to each other, add the 3, and I get an exponent of k, or not, sorry, not an exponent, an answer of k equals 8. All right, so those two are pretty simple because they had the same base. Now we get into problems where you're going to have to find a common base. So if I have 3 on the right and 9 on the left, typically I want to change the larger number into a smaller base. Now 9, I'm going to change the 9 and see if I can find a common base with 3. So look at your know your powers chart from the other day. If I look around here, I can see that 3 can be written as 9, 3 squared. Sorry, I can't highlight on that because it's a PDF, but 3 squared. So I'm going to rewrite this 9 as 3 squared. Its exponent stays the same. That hasn't changed. And I have a base over here of 3. The 3 to the cubed is the same. I have the same base, and I have to remember my exponent rules that if I have power to a power, I'm multiplying those together. So now I have 3 to the negative 6x equals 3 to the third. Because I have the same base now, I take negative 6x equal to 3, divide by negative 6, and my exponent, or my answer is negative 1/2. Same idea in D. I can rewrite 125 to be a power of 5. Now you have to learn that 5 to the third is 125. That's where knowing your powers comes in. But once you know them, and once you get the pattern here, it gets a lot easier. Because both sides of my expression have the same base now, I can take their exponents and set them equal. So I'm going to add 2 and get 3n equals 5, and then divide by 3. So here n is 5 thirds. Let's look at E. This one is tricky. In class, I said that I always want to change the 1. I don't want to change the other base. I want to change the 1 to have the same base as the other side. 3m plus 1. So to keep the 2 the same, can I rewrite 1 to have a base of 2? Well, yes. If you know that anything to the 0 power equals 1, I can rewrite that with a base of 2. Now that they have the same base, I can take the exponents and set them equal to each other. I subtract 1, so I get 3m equals negative 1, and divide by 3. And there is your solution. All right, now F is more challenging because I can't just change the 32 into like 16 squared. I need to change both of their bases, so this is where knowing your powers will help. I know that 16 is 4 squared, right? So if I look at the 4s here, 4 squared, I don't get a 32, right? Not 4 to the third, not 4 to the fourth. So 4 is not going to be my common base. What I have to do, here we go, is look to something smaller. So when I look on my common bases, if I look up at the top here, I see 2 to the 4th equals 16, I'm sorry. 2 to the 4th equals 16. So I'm going to actually rewrite that as 2 to the 4th, because if I look in the same row right next to it, 2 to the 5th is the 32 that I want. So I'll rewrite that as 2 to the 5th, keeping the same exponent of negative 2. Right, now, knowing power to a power, you can multiply those exponents together and rewrite the left-hand side. 2 to the negative 10x equals 2 to the 4th. Now that they have the same base, I set their exponents equal to each other, divided by negative 10. So here x will be negative 2/5. Okay? You still working? You still working? You good?
Yeah, I just can't see.
I'm not doing that trick. I'll keep going. All right, for G, I need to rewrite 25 and 625 with the same base. So if you need to, go to your Know Your Powers chart. Where do I see 25 and 625? Well, they're both in the 5s row. So I'm going to rewrite both of them with a base of 5. 25 is 5 squared. Right? And we still have the same exponent of 3k. 625 we saw was 5 cubed. No, it's not. 5 to the 4th, sorry. Now that they have the same base, I'm going to simplify. This power to a power becomes 5 to the 6k. I set that equal to 5 to the 4th. And then their exponents are equal to each other. So divide by 6, and k equals 2/3. All right, H, 64 and 16. Now there's actually a couple ways you can do this one. So if I look here, I want to see where do I get 64 and 16 in the same row. The first place I see is 4s. 16 is 4 squared, 64 is 4 cubed. You could actually also use 2 though. 16 is actually 2 to the 6th is 64. So actually 2 or 4 could work as the same base. I'm going to use the 4s since I can see them both on my chart here. So we write 64 as 4 to the 3rd. Remember, I have the same exponent. And 16 is 4 squared. Now on the left here, when I find this common, or this new exponent, I'm multiplying 3 times 2x minus 3. So my exponent is 4 to the 6x minus 9 power. And I need to multiply the 3 by both parts of the exponent. Now I can set the exponents equal to each other, add the 9, and then divide by 6. So this exponent is a little funky, but 11 over 6 for that x value. All right, almost there. When we had a fraction, we did a couple like this on the notes in the practice together in class. I need to rewrite both of these with a common base. Well, 36, the only common base I really could have is 6 squared, and that makes sense for the left side. Remember our exponent rule is about negatives. I can rewrite this with a base of 6 to the negative first power, because that would turn that into a fraction. Keep your same exponent of 2m. Now I'm going to multiply the negative 1 and the 2m together to give me 6 to the negative 2m equals 6 squared. I can set both of those exponents equal to each other and divide by negative 2. There we go. M is negative 1. Same exact idea in J. Same numbers even. And use a base of 6. So on the left I'll have 6 squared to that same exponent of 2x minus 3. And the right, I'm going to use a base of 6 again to the negative first power. When I multiply the exponents power to a power on the left, I get 6 to the 4x minus 6, which I can then set equal to the exponent on the right, or set both exponents equal. I'm going to add the 6 to get 5, and then divide by 4. And there's my exponent. All right, I think there's 2 more. Yep, 2 more here. All right, same trick as above. When I have a base, or I'm sorry, a number of 1 here, I'm going to change it so that it's equal to the base on the other side. Well, my base is 49, and a lot of times we want to change that, but I can rewrite this 1 to be 49 to the 0 power. I can just use the same base to the 0 power is going to give me a 1. Now that they have the same base, I can take negative 4x equal to 0, and then divide by negative 4 to get an x value of 0. All right, last problem. 9 and 27. The base I'm going to use, so I look at my chart. Where do I see 9 and 27? Well, in the row for the 3's. So I'm going to change here 9. If I'm making that a base of 3, that's going to be 3 to the negative second power. Keep the same exponent. And the 27 is 3 to the third. Again, keep the same exponent. Now, on both sides, I have to use that power to a power rule. When I do that, I'm going to get 3 to the negative 4n is 3 to the 3n power. Now, the tricky part of this problem is actually the solving for n. I can set both exponents equal to each other. And what I actually am going to do here is I'm actually going to add 4n to both sides. I don't want an x or an n on both sides. I want to move them together. That gives me 0 equals 7n, and then I can divide by 7. So I get again, for the second time, n equals 0. All right, hopefully that helps there for the video for the homework. If you have questions, bring them to class on Monday, and we will do more work then.